Hey everybody, this video lesson is going to take us through the calculations involved in titrations. To begin with, in order to know what's happening in a titration, you need to know what's happening on the chemical level, and that's what's happening is a neutralization reaction. A neutralization reaction is a double displacement reaction between an acid and a base. You mix acid with base together, and what the products are water and salt. In our lab yesterday, we practiced a little bit about using some base up top and putting it into some acid down below. But what's happening inside the beaker is a neutralization. If you think back to chapter 5, that was in December, we talked about double displacements, single displacements, decompositions, the types of reactions. And at that time, we talked about double displacements having two ionic substances, and they exchange their ions. And so the first and the last get together, and in this case, when you put the first and last together, you get HOH. Now, if you rearrange that, what you have is H2O. Now, the other two things that come together are the inside elements, sodium and chloride. We always put the cation first, which is sodium, and chloride in second, which is the anion. And this is where you get the double displacement of the reactants, creating two products. One product is always water, and the other is salt. Water is the product because the H from the acid and the OH from the base combine to make water, and the other substances, sodium and chlorine, are just simply a salt. Now, a salt is a general term for an ionic substance. All acid-base combinations result in water and salt. In yesterday's lab, we mixed acid and base together until the solution turned pink. Now, the reason that the solution turned pink is because the indicator is clear in an acid and turns pink when the solution changes from a pH from below 7 to a pH above 7. But at that moment that the acid and base are equal is known as the equivalence point. At the equivalence point, the pH is 7. Once the titration is over, you know the following substances and information about them. You know the molarity of the base, or M sub B. You know the volume of the base, volume sub B. You know the volume of the acid used. If you remember, in our lab yesterday, this was 0.25 molar. The volume of the base was determined by subtracting the final volume minus the initial volume. That is why you take into account the initial volume and finishing volume, because you subtract them to determine the volume of base used. You also know the volume of the acid used. It was 10 milliliters. The only thing that you didn't know was the molarity of the acid. And I'm going to take you through the calculations involved today to solve for the molarity of the acid. Now, in previous years, this has been done using stoichiometry, but this year I've decided that I'm going to try and do it a different way. I'm going to look at doing the calculation instead of doing in stoichiometry. I'm going to use it as a mathematical relationship where you know all the variables and you solve for the missing variable. Now, before we begin the calculation, it is important that we do know that there is a balanced chemical reaction that this neutralization happens in, and we need to know those stoichiometric coefficients, and so a balanced chemical reaction is essential before moving forward, because the balanced chemical reaction will give us our stoichiometric coefficients. So let's take a look at the formula that I just wrote down up on top. It looks a lot like the combined gas law, but instead of pressure, volume, and temperature, what you're looking at is molarity of acid, volume of acid, and number of moles of acid. And on the other side, it's moles of base, volume of base, and number of moles of base. Now, this volume of acid and volume of base have to be in the same unit. They don't both have to be liters, but they both have to be at least the same. Now, what is N? You might be asking yourself, well, N is the stoichiometric coefficients of both the acid and the base. And in order to get those, you need the balanced chemical reaction. So I'm going to sketch that out now. It's important to note that you will always have the balanced chemical reaction available to you in these problems, at least in our class. And so all you really are worried about is the moles of the acid and moles of the base, and you really don't care much about these other two at all. So let's begin setting up our math. On the left-hand side, I'm going to put all the information I know for the acid. I'm going to start with the number of moles in the stoichiometric coefficients. If you see, there's a 2 in front of the HCl, so I'm going to put a 2 down on the bottom, and there's a 1 in front of the BaOH, so I'm just going to put a 1 down here. Next, I'm going to look in the problem and see what I have available to me. I have the molarity of HCl, so that's the molarity of an acid. But I don't know the volume of the acid, so I'm going to leave that as an unknown. Next, I find that I have 25 milliliters of 0.1 molar barium hydroxide, or base, and so I'm going to write in 25 milliliters on this side multiplied by 0.100 molar of the base. Now if you look carefully, you have all the information you need except volume of acid. And all you need to do is solve for the missing variable using algebra. Now, some people like to cross multiply and divide here, or some people like to just multiply the two sides together and then divide at the end. It doesn't really matter how you do it, just as long as you're consistent. So I'm going to multiply this side at 0.100 divided by 2 is 0.05, and I'm going to divide by 0.05 on each side to isolate VA. And when I do that, VA becomes 50 milliliters, and that is my volume of the acid that I need to neutralize this molarity and volume of base. Now here's another problem that you are dealing with titrating acid and base together. You start with an acid this time of known molarity and volume, and you're trying to calculate what the molarity of the NaOH is. Again, you have the balanced chemical reaction down below, and I sketched it out for you. You have 1 mole of acid for every 2 moles of base. So we can set up 1 mole of acid for every 2 moles of base. Next, I write what I know from acid and base on each side. I know that I have 14.75 milliliters of 0.5 molar H2SO4, so I put those together on the acid side. On the base side, I just have 10 milliliters, and I'm solving for molarity. So this time I'm solving for MB, or molarity of base. Now again, I can divide these quickly and get 5 milliliters, and then divide 5 on each side. Divide by 5 milliliters on each side to get rid of the 5. Now I've isolated molarity of base. If I punch this into my calculator, I take 14.75 times 0.5 divided by 5, and I'll get the molarity of the base, and that's equal to 1.48. Actually, I get 1.475, but I round that to 3 significant figures to get 1.48 milliliters of the base. Now that formula works fine and dandy if you have all the information available to you in a word problem, but we're going to apply this to an actual titration here coming up in our lab. So how and where would I get these numbers? Well, first of all, in our lab, you're going to know the molarity of the base. I'll tell you right now it's 0.25 molar. You're not going to know the molarity of the acid. That's what you're going to be trying to find. Now you will know the volume of the acid because we will initially measure out a certain amount. It's about 10 or exactly 10 milliliters of acid. So besides the stoichiometric coefficients, the only thing that you don't have yet is volume of base, but you actually do. In a titration, you start V initial and you end V final. You titrate until the solution turns pink. Once the solution turns pink, you stop. At that point, you want to take your final minus your initial to get your total volume of base used. That volume of base then can be used. So you have the molarity of the base, the volume of the base, and the volume of the acid, and you're solving for the molarity of the acid. I'll circle the variable up on top. You will be provided a balanced chemical reaction, so you'll have the moles of acid and base, and the only thing you're missing is molarity of acid. So here's a scenario that I'm going to set up. It's a lab-like scenario, and you'll have to do something like this on the test, so pay close attention. You'll be given all of this information. You'll have to summarize it and solve for the missing acid. So up top, you have an initial volume of base and a final volume of base and a known concentration. Down below, you have an initial volume of acid and an unknown molarity of acid, and you've got a balanced chemical reaction to go off of. And you just simply set up the formula and solve for molarity of acid. It's your unknown. So Ma is unknown, and that's equal to times 25 milliliters over 1, because right here, this is all in a 1-to-1 ratio. So that's equal to 0.50 molar times the volume of 10.75 minus 0.20, which is about 10.55. So that'll go here. And that's over 1 as well, because it's a 1-to-1 mole ratio. And I simply solve for M of acid. And my M of acid is equal to 0.211 molar. And that's my final molarity of the acid from this titration. So in summary, you'll be given 5 of the 6 missing variables, and you'll be asked to find the missing variable. Typically it'll be a molarity, but sometimes it might be a volume. You'll need a balanced chemical reaction to find these two numbers on the bottom. If they're 1-to-1 mole ratio, they really don't matter because you're going to be divided by the same number on either side, but typically one will be bigger than the other, so you need to account for it. Solve for the missing variable. That's your answer. That takes care of this video lesson. Thanks for listening.